So this difference of squares was the form a squared minus b squared. The difference of cubes is the form a cubed minus b cubed. Just like for the difference of squares, we decide that we hope a minus b is one of the factors. Here we'll have an a cubed. So I think we're going to want 3 more columns. A times what is a cubed? A times a squared is going to be a cubed. But then what goes in this box? A negative a squared times b. We don't see any a squared times b here, so we must have a positive a squared times b up here. What times a gives me a squared b? Well, ab times a gives me a squared b. Oh, but then ab times negative b is negative ab squared. So we must have a positive ab squared up here. What times a gives me ab squared? Positive b squared. B squared times negative b gives me the negative b cubed I was hoping for. So this is weird looking, but it works. A cubed minus b cubed factors as a minus b times a squared plus ab plus b squared. And notice this factor consists of all possible products of a and b. Just once each, all positive. And just like the difference of squares, this is easy to spot. We have one of these if we're looking at a binomial. Each term is a perfect cube, and the operation is subtraction. Now, deciding if we're looking at a perfect cube might be a little bit trickier than deciding if we're looking at a perfect square. But we should remember that our calculator can take cube roots. So, for example, the polynomial 27x cubed minus 8. We note that 27 is 3 cubed, so this term is 3x all cubed. And 8 is 2 cubed, so this is 2 all cubed. Difference of cubes, cube minus cube. So we factor this as 3x minus 2 times, let's see, 3x all squared plus 3x times 2 plus 2 squared. Oh, it looks like we have a little simplifying to do, don't we? We'll have 3x minus 2 times 9x squared plus 6x plus 4. I'm going to have you try one of these. Factor this polynomial. Pause the video and try this now. Well, we notice that 64 is 4 cubed. So this is 4 cubed minus y cubed. It factors as 4 minus y times 4 squared is 16 plus 4 times y plus y squared. One thing to note, notice that we got a quadratic trinomial by factoring these differences of cubes. The quadratic trinomial that we get this way is always prime. Well, except maybe common factors. But the point is, we don't need to go on and try to factor this further.